Welcome back to the deep dive.
Good to be here.
So this is where we do what we always do. We take that huge stack of sources you've sent our way.
All the articles, the research papers, the internal
When we
memos.
really try to distill it all down to get
Yeah,
to the pure insight you really need to have.
exactly. And for this deep dive, we are tackling the technological and financial earthquake that is AI.
Specifically focusing on this critical moment, this inflection point we're seeing as we head into 2026.
That's the perfect way to frame it. I mean, if you just look back at 2025, it felt like the absolute peak of AI exuberance.
Oh, completely. The manic phase.
The manic AI solves everything, period. You saw the billboards, the rapid IPOs, the breathless announcements every single day.
Right. But our sources, especially some of the notes coming out of Stanford faculty meetings, they're pointing to a really clear shift now.
2026 is it's becoming the year of rigorous evaluation, of, I'd say, necessary realism.
Okay, let's unpack that shift immediately because that sounds like the fundamental question we're all asking has changed.
It has.
The old question was, can AI create a hyper-realistic image? Or can it write a basic essay?
Right. And that question is settled. The conversation is no longer, can AI do this amazing thing?
We know it can.
We know it can. Now, the conversation is focused relentlessly on utility and impact. The new and much, much harder question is, how well, at what cost, and for whom?
So the business metrics, the ethical questions.
The ethical durability, the measurable return on investment, that's what's going to define the coming year.
And that is precisely our mission for this deep dive. We're going to get into the massive technological breakthroughs of late 2025 and then project out.
The economic and ethical implications for 2026, pulling everything directly from the material you've all shared, it feels like a moment of maturation.
Coming of age, almost.
Yeah. And we've segmented this massive story into three really critical areas that I think truly define this new era.
Okay, what's first?
First up, what we're calling the agentic revolution. This is exemplified by systems like OpenAI's GPT-5.
And this is the big transition, right? From a simple reactive chatbot that just waits for your prompt.
To a proactive, you could almost say independent digital partner, a colleague.
Okay. And second?
Second, the creative collapse. The AI video wars. This is where that notorious uncanny valley was, for all intents and purposes, definitively bridged.
Leading to this industrial scale conflict.
Exactly. A war aimed at perfecting the digital world simulation.
And finally, number three.
The economic fork in the road. We have to look at the massive trillion-dollar capital build-out needed to sustain all this, what we're calling the compute wall.
And then contrast that with the highly skeptical market outlook from groups like Vanguard for 2026.
That's a huge story.
Let's get into it.
Let's do it.
Okay, let's start right where this new era really began with the agentic systems. The launch of OpenAI's GPT-5, that was August 7th, 2025. It wasn't just about, better writing or a bigger context window.
No, not at all.
It was a fundamental, conceptual leap forward in how we even expect to interact with AI. The key word here is agency.
And that shift required a monumental investment. What's absolutely fascinating, and this is pulled directly from the source materials, is the sheer foundational spending needed just to switch on this new capability. We're talking about $25 million.
$25 million.
Spent just to build the specialized infrastructure layer necessary to support true, reliable, autonomous AI agents.
And that wasn't for training the model itself.
No, that's the key. That was just the cost of admission for agency, the price to even play the game.
So why that huge, separate foundational cost? What is an agentic system actually doing that a sophisticated chatbot wasn't?
Well, a reactive chatbot, it responds to a single prompt, right?
Yeah.
It gives you an output, and then the interaction is basically over.
Right, it's transactional.
It's transactional. An agentic system, by contrast, is designed to live for days or even weeks. It has memory. It can autonomously break a complex goal down into multiple subtasks.
And it can use external tools?
It can use external tools. It can interact with other agents or APIs. And this is crucial. It has a capacity for reflection.
Reflection. What do you mean by that? It can evaluate its own performance and then adjust its future steps.
Exactly. So if you ask a GPT-5 agent to, say, research and prepare a proposal for expanding our product into Southeast Asia, it doesn't just immediately write a document. It might first query an external economic database. Then it might consult your internal CRM. Then it drafts a three-pronged strategy, realizes one of those prongs requires data it doesn't have, and then proactively schedules a meeting with a human expert to get that data.
Wow. So it moves from being a reactive tool
To a true digital colleague or teammate. It's designed to orchestrate complex workflows toward a distant goal.
That makes the $25 million investment a lot more understandable. You're essentially building a persistent digital employee, not just a document generator.
And the underlying engineering supports that scale of deployment. They're using what's called a unified adaptive architecture.
Meaning the core intelligence can scale across different needs.
Precisely. You have the full flagship GPT-5 for the most complex strategic work. But then you also have leaner, specialized mini and nano variants.
So an example would be Mini might handle all the company's internal scheduling and data retrieval,
Right.
while Nano is embedded in, say, a search engine on your phone.
Exactly. And the full GPT-5 is back at headquarters handling executive strategy. This adaptive scale is what makes broad global application across every industry possible.
It can handle a complex financial analysis and a million simple scheduling tasks at the same time.
At the same time, it's a huge shift.
Now, if this is really the vision for 2026, how do the major industry players see this unfolding in the workplace? I'm thinking of Microsoft, who are, they're betting their entire future on this.
They really are. And Microsoft's Chief Product Officer for AI, Aparna Channapragada, is very, very clear on this. She says AI is evolving from an instrument, a simple tool, to a genuine partner.
And the language they use is really important, isn't it?
It's crucial. The goal is amplification, not replacement.
Okay.
The core thesis is that AI will amplify human achievement. It'll push the ceiling on what a small, talented team can accomplish.
I understand the desire for that framing, but let me push back a little. This is what I suspect a lot of professionals listening are probably thinking.
Go for it.
If the AI agent is handling the how and the scale the data crunching, the content generation, the personalization,
All the heavy lifting.
doesn't that inherently de-skill the human team over time? Doesn't it just make them reliant on the agent's execution?
That is a fundamentally important critique, and it ties directly into some of the skepticism we'll touch on later. But in Microsoft's vision, at least, the human strategic and creative element remains absolutely central.
So what does that look like in practice?
They envisioned a small, maybe a three-person team that can launch a global, hyper-personalized marketing campaign in a few days, something that previously required 30 people and months of work.
Okay, so the humans define the why.
The humans define the why. The strategic objective, the creative theme, the cultural sensitivity. The agent handles the scale, the millions of content variants, the A/B testing, the precise platform targeting.
So the human role shifts entirely up the value chain. You're not paid for efficiency anymore. You're paid for defining high-level strategy and creativity.
That is the crucial takeaway for any professional listening right now. 2026 belongs to those who elevate the human role.
You can't compete with the machine on data processing.
You can't. Or on repetitive execution. You have to focus on optimizing that human-AI loop, on leveraging the agent to achieve an order of magnitude increase in your output and your impact.
Okay, so moving beyond the corporate office for a minute. These agents promise profound transformation in really specialized fields. Let's look at science and health. How does an AI agent, or a lab assistant, as the sources call it, actively join the process of discovery?
Well, as Peter Lee from Microsoft Research pointed out, AI is now moving way beyond just summarizing papers or helping to write reports.
Which was already a big deal.
It was. But in 2026, AI will actively participate in the scientific method itself. Think of it as a super efficient research assistant that just lives in the lab 24/7.
That sounds like something out of a sci-fi novel. What does that actually look like on a Tuesday morning?
It means the AI generates novel hypotheses based on parsing trillions of data points in a way no human ever could. But, and this is the key, it also controls the experiment.
It controls the physical hardware.
It can interface with robotic equipment, execute a chemical reaction, measure the results, reflect on any variance.
And then immediately generate a new optimized protocol.
All of it, autonomously.
Yeah.
It dramatically accelerates the trial and error cycle of science.
That's an immense shift in the speed of discovery. But maybe the most impactful area is medicine. The stakes are life and death. The data is highly sensitive.
Healthcare is, without a doubt, poised for its own ChatGPT moment. That's the phrase experts like Curtis Langlotz are using.
And historically, the biggest roadblock to deploying medical AI was just the cost of training.
The cost and the time, it all came from manual labeling.
You needed highly paid, experienced physicians to sit there and manually label massive data sets.
Exactly. diagnosing thousands of X-rays, identifying specific tumor boundaries on MRIs, meticulously annotating genetic sequences. That manual cost created an impossible bottleneck.
So how are the agents and these new systems getting around that?
The sources are highlighting a breakthrough in what are called self-supervised learning methods.
Yeah.
These are pretty similar to the foundational techniques used to train the big language models in the